All right, good morning. So welcome back. My plans for this morning are to finish going over the midterm, talk about the ODP you just finished, talk about the upcoming ODP, and then just continue talking about string processing, which will be something we'll do probably in a future programming assignment. So any questions before we jump into all of that? Should be sound. Is anybody hearing me? All right. All right, well, I'll keep talking, and if someone's not getting sound, change things around. Cool. All right. So any questions before we go down that agenda? All right. Well, let's continue talking about the midterm then. So we had made our way up to question 4, and we scribbled out some code for that. And these questions sometimes sound, more complex than they actually are. So print all numbers from 0 up to that number, including the number itself and including 0. And if the number you enter is negative, then don't print anything. All of that really lets you get away with just a simple while loop, right? Because if you say, start from 0, and while your counter is less than or equal to the number you put in, if the number is negative, it's not going to loop at all, and it's not going to print anything. If the number is 0, it's going to loop exactly once and just print a 0, and if the number is positive, it's going to print each number from 0 through that entry number inclusive. And so that will work really well. So issues that I saw on this question. Let's see. So not printing a prompt. Using dollar signs correctly or incorrectly. So, and I gave people some slack on varying from what was written up in the notes on Canvas a little bit. But some things that you absolutely have to do. If you want to say, I equals 10, you have to do it like that. If you do $I equals 10, that's not going to work, because it's going to replace this with whatever $I is equal to, and if I is uninitialized, this is going to look like the statement equals 10. It's going to throw an error for you. When you do things like if, right, that would be an if statement to see if I is less than or equal to number. A lot of people didn't put these dollar signs in. Okay, that generally works, but put the dollar signs in to make it clear that you're evaluating a variable here. The one place where I've been very forward with saying you don't need the dollar signs is when you're doing an arithmetic expression, because you've got that in the beginning there, and so you could just say I plus 1, and it'll be the same thing as $ I plus 1. So just keep paying attention to the syntax for if and while statements. A lot of people, if parentheses I is less than num, right? That's absolutely not bash syntax. That would be great for C. But again, Canvas how to bash statements, right? Make sure you follow that guide. If bracket, etc., etc. Same thing with while loops, okay? Small issues with edge cases. Some people would exit the loop a little too soon. Some people would start the loop at 1 instead of 0. That's just algorithm edge cases, right? And that just takes some practice to not only figure out how to write those things just right, but how to run through the code in your head to see if it's doing the right thing. All right, so that's kind of a debugging thing. Oh, so a lot of people printed the numbers from largest to smallest. I didn't explicitly say from smallest to largest, even though I said the numbers from 0 to num. So if you printed them from num to 0, I gave you credit for that. But make sure that you know if you were required to print them from smallest to largest, how to do that. And it's just using another variable, which is something we're going to get into with the new ODP. All right, let's go on to question 5. So question 5, most people nailed. That was a bash program that basically goes in a loop, asks a user to enter a number, and if it's positive, print twice. If it's negative, print 3 times. If it's 0, then exit the script. And so you might do something like this. And I'll do this one with sort of a proper loop instead of a forever loop that we break out of. So I could echo a prompt. I could read num. You can do read -p with a prompt. You can do echo -n to leave it on the same line. There's all sorts of freedom there. So my while loop would be while num is not equal to 0. And I'd rather do this than num exclamation mark equal quote 0. Because technically if the person types in 0, 0, I should accept that as a 0. I didn't take off for that. But if you're comparing numbers, use -eq, -ne, stuff like that. So while that's the case, do the following. If num is greater than 0, then echo num times 2, else echo num times 3. End of the if statement. It can't be equal to 0 because if it was, we wouldn't be in this loop. So those are our only conditions. And then echo a prompt and read a number. And then that's the end of our loop. So that's a standard way to do a infinite loop until some condition occurs. So if the number they enter is 0, that'll kick us out of the while loop and we're at the end of our script. So anything like that would work fine. And like I say, most people seem to get that pretty close to correct. A few people squared the number instead of multiplying by 2 and cubed it instead of multiplying by 3. So I don't know what that was about. If you inadvertently printed the 0 when the 0 was entered, I didn't take off points for that. But technically, you're not supposed to print a 0 when the 0 is entered, right? If it's positive, print twice. If it's negative, print 3 times. 0 is not positive or negative; it's just 0. So you should exit. And let's see, anything else in there? There were some cases where nothing like this was going on. There was no comparison to 0 and things like that. So so it wasn't always clear what the intent was. Question 6, which was actually questions 5 through 9, didn't see a whole lot of issues in here either. So make a directory named work under your current directory. That's just makedir, mkdir, and change into that directory. That's just cd space work. Compile a C program, main, to create an executable program, gcc-o program, main.c. And most people got that. List the files in your directory, ls. Add main.c to the staging area, that's git add main.c. Commit it to the repository, that's git commit. And then make a copy of main.c, that's just copy main.c, main2.c. Alright, so again, if you have questions that you don't want to or can't ask here, or questions specific to your answers and points I took off and so on, catch me in office hours. So office hours today, office hours Friday. all good options to come by. All right, any other questions? All right. So I mentioned yesterday the idea of working on practice problems, and I just wanted to give you one such resource. W3resource.com is a good site. I don't have anything to do with them, but I've looked at it and it seems decent. It's most useful, I think, because it's got a ton of exercises, right? Practice problems. So list of C programming exercises, basic declarations. Write a C program to print your name, date of birth, and phone number. Write a C program to get the C version you are using. Well, we haven't gone over that. So write a C program to print a block F using hashtags. Write a C program to compute the perimeter and area of a circle with a radius of 6 inches, right? So some of these, will be laughably simple to some people, in which case, don't do them. Some of them will seem pretty obvious to most people, but not, necessarily 100%. Do one or two of them. If they're straightforward to do, move on. Some people will find these earlier exercises to be something that would take a bit of work to actually write code for, that would run, the first time. Spend some time doing this, right? It's all about practice. Write a C program to read an amount, an integer value, and break the amount in the smallest possible number of banknotes. Well, that's something we're doing in 215 this week. Convert a given integer in seconds to hours, minutes, and seconds. That's a fantastic exercise, right? It's something you do end up doing in daily life. Okay, not everybody, but I do. And if you know how to do it, it's not a big deal, right? But if you've never done it before, it's a really good thing to think about. These are the kinds of things that are the best possible practice you can do to get better at programming, right? And all of these questions are for, basic declarations and expressions, basic algorithms. Write a C program to compute the sum of two given integer values. If the values are the same, return triple their sum. Right? So it's some input, and it's some parsing, and it's an if statement, and it's a print statement. But if you want to get better at those things, right, write some code. And there's, lots of questions in each of these. Write a C program to create a new array containing the middle elements from the two given arrays of integers. Right, so this would be my suggestion if you want to get better at programming in general and C in particular, right? Play around with this stuff. And it gets, more and more complex. Write a C program to demonstrate the use of the ampersand and star operator. Well, that's a little vague. Write a C program to find the factorial of a given number using pointers. So you're welcome to look at that. I'll post the link in the chat window. And all you need is W3 resource. You can find everything from there. And they have different languages in here. And they get into more and more stuff. So linked list, that's 222. Recursion, that's 222. File handling, we'll do a little bit of that. So anyway, that's out there for what it's worth. If you like it, good. There's other resources out there also. All right. right, let's see. One comment on homework 6. I had one person ask me. So, writing homework assignments is an art that I've never gotten very good at. So I originally said, in your Git repository, I want a make file, a README, your source files, and nothing else. And then somebody asked me, does that mean we should remove all of the files that go along with the Git repository? Because in your home directory, there's a .git repository, and you might have a .git ignore, and so on and so forth. And I didn't mean that you can't have those in your Git repository. Those need to be in your Git repository for it to be a Git repository. So I updated the assignment and I said, go ahead and include those. And then I got emails from people asking how to add these to the Git repository. Okay, so my intent was, don't worry about these files. They are automatically in your Git repository. You don't have to add them, you don't have to remove them, right? But the files that you put in your directory, I only want the make file, the readme, and the source files, .c's, .h's. All right. So if you were worried about how to put the Git files in there, don't worry about it. Okay, it just happens automatically. All right. Let's see. All right. Let's talk about the latest ODP. What about .o files? No, that's specifically something I wanted excluded. Do not include your .o files. Do not include the executable file. Okay, just put in the source files .c, .h, your make file, which is required, and a readme, which is required. What should be in the readme file? Your name, the date, the class, the name of the assignment, and a synopsis in your own words of what this project is about. Okay, don't just copy and paste from the assignment. Paraphrase it. Okay, put it in your own words, and that should be fine. That does not mean you don't have to put comments in your code, though. Okay, you still need comments. Alright, let's see. Quick question, homework 6. When I compile, it throws a series of warnings that I'm comparing a car star to an int. I've thoroughly tested and it runs as needed for the homework specs. Is that okay? It's a gamble. Anytime that you're getting warnings, there's something you're not doing right. And in C, a lot of times you're not doing things right, but the code still works sometimes. But, part of my job is to try to break your code. And I'm pretty good at it. So if there's something in there that's not quite right, there's a chance it will come up when I test. If you're getting a message about comparing a car star to an int, it's exactly what it sounds like, right? Somewhere you have a variable that's declared to be a string, an array of characters, or a car star, and you're checking to see if it's equal to either a character or an integer value, or quote \0, something like that. It should tell you exactly where it sees that in your code, though, right? It should tell you which line number that's happening at. Go ahead and look at that and just look at both sides of your comparison and see if they're both ints or they're both pointers, right? What they should be, see if they both are that. And you can definitely send me, a copy and paste from your terminal session of your code and the compile message that came along with it, and I'll be happy to help you look at that. Just send that as a plain email. All right. So ODP 409. You were writing this revised version of your square root program that would take an argument and then print out its square root, but would also do error checking. And we went through the details of how to do this yesterday in terms of which steps to follow, which I mentioned are, exactly in the order that they're given here. First, check to see if you have exactly one argument. If you don't, error out. If you have one argument but it's not parsable as a double, error out. If it's one argument and it's parsable but it's not non-negative, error out. Otherwise, do what you did in 408, print the square root, right? But before you can test that argument to see if it's a double, you have to make sure you have an argument to test. So if you wrote your code in a different order and the first thing you did was an scanf on argv bracket 1, you're going to segfault if there's no argument, right? So anytime that you work with command line arguments, always make sure that argv bracket whatever exists by checking argc and making sure that it's large enough to say argv bracket whatever does exist. And so this was the code for 408. This was 2 days ago, right? So take a pair of arguments into main. 408, we assumed everything was hunky-dory, so we just scanf argv1 into a variable x, take the square root, print it out. For 409, same thing at the end, but you have to do some work in the beginning. So first thing you do, make sure argc is 2. If it's not 2, print an error message and exit. If argv bracket 1 exists, which you know because argc is equal to 2, go ahead and scan it, pick up the extra stuff, save the result from scanf in a flag variable. If that flag is not 1, error out. At this point, we know that we had a valid argument. We know that we parsed it successfully as a double, and the value of that argument is an x. So now check to see if x is negative, and if it is, error out. Otherwise, blah, 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 all of that is satisfied. X is the number we're supposed to take the square root of. There's ODP 408, take the square root, print it, and you're done. All right, another email I got from somebody, and this was pretty cool. /temp/s1 main, right? This was a sample code. I don't know what I called it, S1 pub. So this was the sample code to play with for ODP 409. So, if you do 25, it prints out the correct value. If you do 25 with extra stuff after it, it's supposed to print an error message. And somebody observed that if you, put a second argument like this, it doesn't error out, right? And that's okay, because remember, number sign is a comment in bash. So even though it looks like I'm calling this program with 2 command line arguments, I'm really not. The number sign is a comment that's not being given to my program. So this came up with homework 6. Homework 6 is supposed to play high-low. I don't even remember what I called it. That was called main. So you can put in a pair of numbers to specify the range, but if you do this, right, it's going to take that as just running without any command line arguments. Those number signs never get to your program. Okay, they're just comments. Alright, if I had 3 statements within each other and it worked, is that bad code? No, not at all. So back on the ODP 409 code, I wrote them out sequentially because I was planning to show them to the class, and it followed the order of things you had to check according to the assignment. But yeah, doing them in one statement is fine as long as you do them in the right order. So if argc equals 2 and something with argv bracket 1, right? This should work fine because I'm doing a logical and. The first thing it's going to check is argc equals 2, and if that fails, it's not going to do this part of the if statement because it doesn't have to. If you're anding things, as soon as it finds something that's false, it's going to exit out. But if I did this in a different order, if I said if, scanf argv bracket 1 and argc equals 2, and I run my program without a command line argument, this gets evaluated first, it's going to segfault. Right? So the order is important. And if you want to flip this around, this would be testing for a good condition. If you want to test for a bad condition, you would do a disjunction if argc is not equal to 2, or, can't scan argv bracket 1 or less than 0. You're not seeing any of this wonderful stuff that I'm writing. Alright, so the order is important. If you write this, it'll check to see if argc is 2, and if it is, then it'll try this. If argc is not 2, it won't bother doing this because as soon as this fails, it knows the whole if statement condition is false. If you wrote this in this order, you're going to get a segfault if there's no arguments, because the first thing it's going to do is see if argv bracket 1 is parsable by scanf, and it's never even going to make it to see if argc is 2. And then if you want to do this in the other sense, right, if you want to test for a bad condition, I could first check if argc is different from 2, or I can't scanf argv bracket 1, or the thing that I scanned was less than 0. That'll work perfectly fine. Right? Because if this fails, right, if this turns out to be true, if argc is not 2, it's not going to do any of these other expressions because it doesn't have to, because I'm ORing these things together. All right, so let's talk about ODP 450. So the goal here is to write a function named clean, which will take a string argument and modify it. Okay, it doesn't return anything, so you declare it as void and make sure it's void, not a pointer to void. Just void clean parentheses char star. And as usual, when you write the function, you have to give a name to this variable. So it takes in a string, it removes all occurrences of an uppercase X in that string, and then it just returns. That string itself gets modified. Okay, so you passed in an argument, and when you come back from the function, the argument that you pass will be changed. Alright, so let's talk about how to do this first, this particular assignment, and then let's play around with passing strings and modifying them and seeing that modified value comes back. So I'm allowing you to use two functions here, string copy and string length, and you're not going to be able to use any other functions unless you write them yourself, because you can pull in a regex package and do this with one line without doing any work. So you can do string copy and string length. Okay, so how would we do this? So let's sketch out some code. So I'll make my function called clean. I'll pass in some argument. And the other thing I've told you here is that you can assume that your argument is not going to have more than 120 characters in it. Okay, somewhere in here I say that. Well, I meant, oh yeah, there you go, okay. So you can assume the incoming string is not null, so you don't have to check for segfault. So it is pointing to a string, and that string has no more than 120 characters. And that's important, okay? That makes it a little easier, makes it a lot easier to do this. So here's one approach to this, and this is the approach I recommend you take. Suppose somebody handed you a string which said, you know, HEXLXXOX. And they said, hey, can you remove all the uppercase X's from this string for me? Well, here's one way to do this. All right, I'm going to start at the beginning. Is that an X? No. Is that an X? No. Is that an X? Yeah, that's an X. I'm going to get rid of that. Well, that's not a word now, so I'm going to change this to an L, and I'll move that X down to there, and I'll move that second X down to there, and I'll move that O down to there, and I'll move that X down to there, and I'm going to get rid of that. All right, where was I? I was here. Okay, there's another X. I'm going to get rid of that, right? That's not what you want to do, okay? That's painful to do on paper. It's even more painful to write in code, okay? You can do it, and if you didn't know how long the strings were ahead of time, that would probably be what you'd have to do. But that's a pain. It's really, really unpleasant bookkeeping-wise, and you know, I may give that as an assignment someday. But there's an easier way to do this, right? I mean, how would you and I do this? We would take this and we'd say, okay, H, E, no, L, no, no, O, no. Okay, there's your string. In other words, I would look at the original string and I would make a new string that simply copies all of the characters that aren't in uppercase X. And that's a good algorithm to do for ODP 450. Now, how exactly did we do that? Well, I created a new string down here, and the letter H, you know, first letter becomes the first letter, letter E, second letter becomes the second letter. The letter X I don't want to copy, so I skipped the third letter. I went on to the fourth letter. Where did I write it? In my output box. I didn't write it in the fourth position, I wrote it in the third. And here's the fifth and sixth letter, I'm going to skip those. Here's the seventh letter, but I'm not going to write it in the seventh position, I'm going to write it in the fourth position. Well, how did I know that that went in the fourth position? Well, I kept my finger here, and I moved it over, and if I had another letter here, I would put it where my finger was, and I'd move my finger over. Okay? My finger is just a variable. So here's some pseudocode. Start off with an output location. Initialize it to 0. Make an output string, which you can make a fixed size of 120 characters because we know the input's never more than 120 characters. Alright, for each character in our incoming string, let's do the following. If it's not a letter X, let's copy it to output bracket output location, and then let's increment output location. and do all of this inside a for loop. And that gets you most of the way there. Okay, so does this make sense that this is doing this, right? We're going through each character, we're starting with an output location of 0, and each time we find a character we want to save, we just copy it to the current location in our output, and we bump up that location. So when we're done, our output loc will be pointing to the next spot where we want to store something. Okay, and this is the edge case thing to think about, and there's different ways to do this. Output loc is starting at 0. When we find a character to save, we copy it to output location, and then we increment. So output location is always one spot past our string. It's pointing to the next place we're going to store something. Alright, and if you do this, you'll segfault. Okay, unless you add one more thing. So the other thing you have to add here is a null terminator. Because if we just go through each character, we're going to end with an E. This is not a proper string yet. Alright. And there's all kinds of ways to make sure there's a null terminator. You can go through and you can start off by initializing this to 120 null terminators. That's way more work than you need to do. An easy way to do this is once you finish your for loop, since we know output loc is pointing right here, just throw your null terminator right in that spot. And now output is your cleaned up string. It's your string with all the x's removed. A different possibility is in your for loop. Just make sure you iterate not over all the characters, but all the characters and the null terminator. Alright, so how do you iterate over all the characters in a string? For iterator variable equals 0, I less than string length of your string I++. Okay, standard for loop for going through an array. So I starts at 0, it goes up to and including string length -1, which will be whatever the last character is. If instead I do I less than or equal to, the last time through this loop, I will be pointing to the null terminator. And since it's not an X, it'll get copied to the output, and I don't have to do this extra step at the end. Either way, but ideally make sure both of those approaches make sense. Alright, questions about this so far? Alright, so this leaves you with a new variable called output, which is the cleaned up version of your argument. So the last thing you need to do is a string copy. Okay, string copy will take this character array and copy it into that character array. So it'll take the cleaned up array, copy it into the original, and then you're done. Alright, now if we didn't know anything about the lengths of these character arrays, this would be a dangerous thing to do. But we know that our argument is never more than 120 characters, so we're not going to get into trouble doing this assignment. And we know that our output array is no bigger than our original argument. It's probably smaller because we got rid of a few characters. So this string copy will be safe. If you haven't played with string copy, take a look at the manual page for it. It's one of the unusual C functions in that the destination comes first instead of last. But it basically copies from a source array into a destination array, up to and including the null terminator. Alright, questions, that's all you need for 450. I'm not going to go over this again this afternoon in emails, because all I can do is tell you this again, right? So if you have questions, if any of this is not clear, please ask them now. Or if you want me to go over any of this again or differently. Another option is, you could begin by copying your argument to another string and then copy from that string into your original argument, and then you could avoid the string copy at the end. That's totally fine. Alright, so test your program. Make sure it doesn't produce any output. Make sure it doesn't read any input. It's just processing an argument silently. Put your function in a file named clean.c. When you're ready to assess, make sure there's no main program in there. It's just a file containing that function. And then compile as usual with the test bed. And then assess it as usual. Executable program and source code file. Alright, so let's play a little with passing strings as arguments in C. I don't know if we need string in here, but I'll put it in anyway. So let's just pass this string to a buffer, and then let's print out our buffer. Alright, and someone asked about the difference between char star and char string bracket. So that's apropos because we're about to dig into that. So let's see if this helps. Let me prototype my function. So in my function prototype, all I know is that this function is supposed to take a character array, a string. I don't know if it's going to be 10 characters or 120 or 1,000. So I would not want to prototype it as char bracket 120. Because that would be a very specific function. So here I'm just going to say char star. In my main program, I want to actually allocate 120 spots in memory to hold whatever gets typed in. So here I need to say I want buffer to be 120 characters. Alright, but in my function itself, here again, I don't know how big my argument's going to be to begin with. Now, if I knew that my argument was always going to be 120, I could say character arg bracket 120. But that's a very particular case. If you don't know how big it's going to be, it's got to be a char star. But it's okay to be a char star here, because what's going to happen? I'm going to call the do stuff function. I'm going to pass an argument which is buffer. Buffer is a char star. It's the address of a character in memory. When I pass that to do stuff, down here the value of this variable arg is going to be buffer, right? But since buffer was declared to point to a block of 120 characters, arg is also pointing to a block of 120 characters. All right, so so what should we do? I don't know. Let's just truncate this string to 5 characters. So we'll just say arg bracket 5 is the null terminator, and we'll just return from there. All right, so this is our test code. So I'll say this is a test, haha, and it comes back this I. If I pass in hello, it comes back hello. If I pass in hi, it comes back hi with a new line at the end. All right, now if I didn't do this, if I just did car star buffer, right, I'm going to get a seg fault. Why am I getting a seg fault? Because when I say car star buffer, buffer is probably equal to 0 or some, random value that I haven't assigned. And when I try to do an fgets, I'm saying read characters from the user and save them in memory at this address, which is pointing, just some random location. That's what generates the seg fault. But down here, when I say car star, arg is not an unassigned value. Arg gets its value from the argument that I passed to it when I call do stuff. So as long as buffer has a legal value up here, arg down here will have the same value. That'll also be legal. Yes, exactly. So car star should only be used if you know that the string has actually been given a value, or will be given a value. Given a value, and in particular a value which is pointing to some spot in memory that's accessible. All right, let's see. Is there a way to return more than one value from a function? Not with just a simple variable type, but you can return a structure which can contain a bunch of things, or you can return a pointer to a structure, or a simpler case, a pointer to an array, which would have multiple values. So yeah, depending on what you want to do. Let's see, ODP 450 works perfectly when I run it, but when I try to assess, I get 0. Yeah, so working perfectly is part of what we're trying to figure out, right? Looking at exactly what something's supposed to do in all cases and confirming that that's exactly what it does. All right, and one other thing I wanted to say that I've told. Oh, permission on 452. I haven't finished posting 452 yet, so those aren't readable yet. But I'll unlock them shortly. All right, we're good to go. Have a good one. I will catch you next. If we copy, I'll catch you next time. If we copy output over to the input, does it delete the input or just overwrite some of it? It'll basically overwrite some of it. Like when you do the string copy, if there's 5 characters here in a null terminator, it will overwrite 6 characters in there. The 5 characters in the null terminator, and everything else will stay untouched. And you can actually write a loop and go through and look at each of these characters one by one and sort of see exactly what string copy does. All right, cool. I will catch you next time. Thanks.